Hello everybody. In my last video, I went over some thoughts that I've been having about the concept of purpose and freedom, and in this video, I'll be returning to the Kalam cosmological argument to talk about infinity and the role that infinity plays in the Kalam. If you're unfamiliar with the Kalam, and if you're unfamiliar with the difference between a potential and an actual infinite, then you can click the link right here or click the link in the description to go watch an overview video that I have of the Kalam in which I go over those things. And before I get into it, I would just ask that if you like the video, click the like button. And if you really like the video, you can subscribe to keep up with my newest videos. So, with that said, let's get into the video. The second premise in the Kalam is that the universe began to exist. And there are typically two ways people go about defending this premise. There are a number of scientific arguments which attempt to show that our local universe must have had a beginning, and at least one argument which attempts to show that all of space-time must have a beginning. But there are also philosophical arguments. These arguments typically center around two claims. First is the claim that an actual infinite cannot exist in reality. If nothing in reality can be actually infinite, then the past can't be actually infinite. Second is the claim that you cannot form an actual infinity through the process of successive addition, that is, adding one thing after another, after another, after another. If time is just a series of events happening one after another, after another, after another, and you can't form something actually infinite through successive addition, then it follows that you can't form an actually infinite amount of time through simple succession of events. So, what reason is there to accept these two arguments? Let's start with the first. The argument, according to the Blackwell Companion of Natural Theology, goes as follows. Premise 1. An actual infinite cannot exist. Premise 2. An infinite temporal regress of events is an actual infinite. Conclusion, therefore, an infinite temporal regress of events cannot exist. What reason is there to accept the first premise, that an actual infinite cannot exist? The main reason comes from all of the absurdities that arise if it is possible for an actual infinite to exist in reality. Perhaps the most famous thought experiment to illustrate these absurdities comes from the mathematician David Hilbert, and the illustration is called Hilbert's Hotel. Imagine a hotel with 100 rooms, each of which is full. Now imagine that a man comes into the hotel and asks the clerk for a room. The clerk obviously can only do one thing, say, sorry, we're all full, and show the man the door, pretty much. So that's the end of that story. But now imagine a similar scenario in which there is a hotel with an actually infinite number of rooms, each of which is full. Just like before, a man comes along asking for a room. This time, however, the clerk says, no problem. The clerk goes to room 1 and politely asks the guest in that room if they would move to room 2. Then he asks the person in room 2, could you move to room 3? He moves the person in room 3 to room 4, the person in room 4 to room 5, and out to infinity. As a result, room 1 becomes vacant and the new guest is accommodated, despite the fact that every single room was full. But here's where things get really interesting. Imagine now that there's a bus arriving at the hotel, and the bus is carrying an actually infinite number of people. The bus driver gets out of the bus, goes into the hotel, and says to the clerk, "Yeah, I've got a bus of an infinite number of people, and I was wondering if we could get a room here." The clerk says, "No problem." He takes the person in room 1, moves them to room 2. He takes the person from room 2 and moves that person into room 4. He takes the person in room 3, moves that person to room 6, and so on out to infinity. If you can't see what he's doing already, all he's doing is taking the room number and multiplying it by 2. Now, any number multiplied by 2 always equals an even number. So what does that mean? That means all of the guests that were in the hotel are now in even numbered rooms exclusively, which means all of the odd numbered rooms are vacant. So you ask, how many odd numbers are there in an actual infinite? Well, an actually infinite number of odd numbers. So this new bus of infinite guests can itself be accommodated. We took a situation in which there's an infinite number of people in the hotel already filling up all the rooms, and yet through simply moving people around, we're able to accommodate another infinity into the hotel. In fact, there could be an actually infinite number of these buses, each of which contains an actually infinite number of people. And all the buses could be accommodated simply through moving people around the hotel. Even stranger is the fact that despite these infinities of new people are arriving, the number of guests in the hotel from when it started to when the process is finished is literally exactly the same. There are no more people in the hotel than there were before this infinity of infinities showed up. It's the exact same number. Namely, it's an actual infinite. Now, up until now, all we've done is try and add new people to this hotel. But the real oddities come out when we try subtracting people from the hotel. Let's say that one person leaves the hotel. Now, how many people are left in the hotel? Well, an actually infinite number of people. There's no less people in the hotel than there were before, even though a person left. But nevertheless, it's just one person, and that ultimately resulting in an actual infinity doesn't seem that absurd. It seems fairly regular. So in this case, infinity minus 1 equals infinity. What if 10 people leave? Well, you've still got an actually infinite number of people. So infinity minus 10 equals infinity. What if all the people in the odd numbered rooms leave? This is a bit more interesting because now we're subtracting infinity minus infinity. The only people left, of course, are the people in the even numbered rooms, which means that the hotel only has an actually infinite number of people still in it. So we took away an actually infinite number of people and we're left with an actually infinite number of people. So in this case, infinity minus infinity equals infinity. Now, you might be thinking to yourself, oh, I see. Infinity minus anything always equals infinity. And I mean, that makes sense, but it's completely wrong. Imagine that every person in the hotel, except the people from rooms 1 to 10, leave. Now, how many people are left? Now, keep in mind, the exact number of people are being subtracted this time than when we made all of the odd numbered people leave the hotel. And yet this time, the answer isn't infinity. Everybody except the people from rooms 1 to 10 have left, meaning there's 10 people left. So in this case, infinity minus infinity equals 10. You can do this with any set of rooms. What if the people from rooms 1 to 50 stay, and the rest leave? Well, infinity minus infinity equals 50. What if rooms 1 to 1 trillion stay, and the rest leave? Well then, infinity minus infinity equals 1 trillion. Infinity minus infinity doesn't have a consistent answer. And this is well known in transfinite arithmetic. Transfinite arithmetic doesn't allow you to subtract infinity from infinity precisely because there is no definite answer to it. It is left undefined. But as William Lane Craig has said, you can slap the hand of the mathematician who tries to subtract infinity from infinity, but you can't stop someone from taking away a certain number of coins. Similarly, just because you're not allowed mathematically to subtract in this way, nothing is stopping the hotel guests from leaving. Now, Hilbert's Hotel is a place of complete absurdity. The idea that you can accommodate infinity after infinity after infinity of new guests simply by rearranging where the guests are in the hotel seems ridiculous, frankly. Similarly, the idea that you can take one value, subtract it by another value, and get a certain answer, then do that same thing over, subtract the identical quantity from the identical quantity, and come up with a non-identical result, just seems ridiculous. But what causes these absurdities? It's obviously not the physical building, or the clerk, or the fact that there are people in the hotel. The absurdity lies in the presence of actual infinities. This is made obvious by the fact that when you get rid of the actual infinities, the absurdities go away. If you have a finite number of people in the hotel, then nothing absurd results. It's only when you invoke actually infinite things that these absurdities arise. If actual infinities can possibly exist, then a place like Hilbert's Hotel can possibly exist. But given the absurdities associated with Hilbert's Hotel, it makes sense to think that no such hotel could ever actually exist. Defending premise 1 took a little while, but luckily premise 2 is significantly easier to defend. You'll recall that premise 2 states an infinite temporal regress of events is an actual infinite. This, I think, is virtually undeniable. If the number of past events is not finite, then it is infinite. It is infinite. This seems pretty obvious. The question then is whether it's a potential infinite or an actual infinite. But think about the nature of the past. Part of what it means to be the past is that these events have actually happened. They are not just potentially going to happen, they all have really been actual events. It doesn't make sense to talk about the past as if it's a potential infinite. It's not like the past is finite, but growing indefinitely in the opposite direction of the future. Thus, if the past is infinite, it has to be an actual infinite. But no actual infinite can exist in reality. So the past can't possibly be actually infinite, which means it must be finite. There must be a beginning. So that is it for this video. I hope to have given a fair overview of this first argument against the existence of an actual infinity. Thank you very much for watching. If you liked the video, be sure to share it with someone you know, and subscribe to keep up with my newest videos. If you feel like you have something to say, you have an objection or an idea, or just you want to leave a comment, feel free to leave a comment. I absolutely love getting comments. In my next video, I'll be giving an overview of the second argument against actual infinities. So, stay tuned for that video, and I'll see you then.